So let's look at the following example. Suppose a certain type of plane accelerates at a constant rate of 3.0 meters per second squared and requires a velocity of at least 33 meters per second before actually taking off from the runway. Now, let's look at part A. Assuming our runway is 120 meters long, will our plane take off with this acceleration and given the fact that our runway is 120 meters? So, here's our runway. Our displacement is 120 meters. So our initial position is 0 meters. Our final position is 120 meters. Now, our initial velocity of the plane, we're going to make the assumption, is 0 meters per second. Our final velocity that we need to reach is 33 meters per second. Now, what we want to find in this example, in this problem, is what is the final velocity of our airplane given that it will travel 120 meters at an accelerating rate of 3.0 meters per second squared. So we have to use one of the equations that will allow us to find the final velocity of our plane. And then we compare that final velocity with this given velocity. So let's use the following formula. Our final velocity squared is equal to our initial velocity squared plus 2 times our acceleration multiplied by our displacement. So x final minus x initial. Now, we want to make sure we have velocity on one side without any square. So let's take the square root of both sides. This 2 cancels, and we're left with the following equation. So now we simply plug in our knowns. So we know our initial velocity is 0, so this term cancels out. Now, our acceleration is 3 meters per second squared. Our displacement is x minus x initial, so that's 120 minus 0, so it's simply 120. So we have 2 times 3 times 120 is 720 meters times meters, so meters squared divided by second squared, and you square this whole thing, or you take the radical of it. Now, plug this into the calculator and we find that our velocity, final velocity of our object, our airplane, is approximately 27 meters squared. Now notice this velocity is not the same thing as this velocity. It's less than that. That means our airplane needs more room to travel to reach this final velocity. So that means our runway is not long enough and our airplane will not be able to take off. Now, in part B, how long should the runway be for the plane to actually take off? Now, before we find the actual distance our airplane needs to travel, we need to calculate the amount of time the airplane requires to go from 0 meters per second to a speed of 33 meters per second. Now we know what our acceleration is, so let's use the following formula. Our v final is equal to v initial plus a times t. So we know what our v initial is, it's 0. We know what we want our v final to be, 33 meters per second, and we know our constant acceleration. So 33 meters squared is equal to 3 meters per second squared times time. We bring our 3 over and we get our t. Our time is equal to 33 meters per second divided by 3 meters per second squared. Our meters cancel and we're left with 11 seconds. Now, instead of using this formula, we could have simply used logic. Look, our plane accelerates at a rate of 3.0 meters per second squared. That means that every second our airplane adds a velocity of 3 meters per second. So after 1 second our velocity is 3 meters per second. After 2 seconds our velocity is 6 meters per second, and so on. How many seconds does it take to get from 0 to 33? Well, it takes 11 seconds because 11 times 3 is 33 meters per second. So, now we know the amount of time it requires for our plane to go from 0 to 33. So now knowing our final velocity, or now knowing our time, we can use the following formula to solve for our displacement. So, our final position of the runway equals our initial position. We're making the assumption that it's 0 plus our v initial times t. So this term is 0. This term is 0. We see that here. And that we get plus the last term. So 1/2 times our 3 meters per second squared multiplied by 11 seconds squared. So we get 3 times 11 squared. So this is 121 times 3. That's 363 divided by 2. That's 181.5 meters. Notice the seconds squared cancel. We're left with meters. And this is our final runway distance.